All right, so the quick revision. So what we have done till now, we draw the cam profile. The case number 1 was the follower was knife edge, which means just a point contact, and it was in the line of the rotation of the cam. The second case we did was cam, okay, but it's again knife edge, which means a point contact, but it was little bit offset from the axis of rotation, okay, so that we need to modify some geometry to draw it. Now this one is pretty much the same as the first one because it is in line, okay. The follower is in line of the cam, but with the roller, not the knife edge. So we can go on and we can have more and more possibilities like roller, but it is offset and this. Our purpose is not to cover everything. Our purpose is just to learn how to make cam profiles, and then which can obey the required displacement diagram. So we are going to make this displacement diagram for this one. So draw the cam profile of a cam operating at the roller reciprocating follower with the following data. So you can see that you need to see that there is a roller attached to it. Okay, the minimum radius is how much? 25. So we say RC, which is the cam basically 25 mm. The lift, which is H, is 30 mm. And you do remember that most of the time I'll give you these lines, okay? So it may not be 30, it can be 32, 28, something, but whatever it is there, try to use it so that you can save few minutes of drawing the displacement diagram. I know it won't take much time, but it's like just to go further deeper into it. I don't want to draw the displacement diagram. Okay, H. The roller diameter. Okay, so this is one of the big problem with the students. What is the problem? They do not differentiate between the diameter and radius. When you use the compass to draw something, it is basically a radius. Okay, because you open it to the radius and you put one point at the center and the point at the circumference. So it's basically the radius. So we need to convert this. You know the formula of this? Convert diameter into radius. So 15 divided by 2, it would be, okay, since it is 7.5, you need to be careful because on most of the scales, millimeters are given, but point least count is not there. So you need to be very, very careful and do it. The cam lift the follower 120 degrees with the simple harmonic motion. So the lifting is, which we usually denote at phi A, is 120 degree and simple harmonic motion. And then dwell for 30 degrees. Then the follower lower to 150 degrees. So phi D is 150 degrees with uniform acceleration and deceleration followed by the dwell period. So rest is dwell. Since we decided we'll stick ourselves to two conditions only. One is simple harmonic motion, another is uniform velocity. Okay. We can do this thing as well, uniform. There's only some geometry is changed. But if we cover everything, so it will become like engineering drawing course, which I don't want it. We just want to look at it, how to do it, and then other things you can add it later on if it is really required to draw a cam profile. Okay, so we stick ourselves to uniform velocity or simple harmonic motion. What do you prefer between uniform velocity and simple harmonic? So all of you wants to have a uniform velocity. So uniform So there is a change in the condition because we want to restrict ourselves to this. If the cam rotate at the uniform speed of, then there is n. The formulas are given over here. You need to learn how to use these formula by yourself. The solution is already there in the lecture note. These scan pages are available over there from the book. Okay, so what we need to do now? There's a small difference in drawing the first circle. So usually what we are doing, we draw the RC. Okay, which was basically the cam minimum radius. But since there is a roller involved over here, so we have to draw RC plus R minimum radius plus roller radius. Okay. Once we draw it, so it's a minimum radius plus roller radius. And on the top of it, you can draw, if you want, you can draw, otherwise you can leave it. Later on we need it, is the roller. Okay. That's the probably the only difference. The two difference, one is this, another is at the end. So what we need to do now, we'll consider everything with RC plus R, roller radius. Okay. And then when we complete this rest of the process, we will offset it to the value of RC. That's the second difference. Okay, understandable? So once we make a basic circle, then we need to divide it into so this one is phi A, which is in this case is 120 degree. This one is delta 1, which is 30 degrees. And then we have this one is phi D, which is 150 degrees. And then the rest is delta 2. You can measure it how much it should be. The rest of the angle, 360 minus all three angles. Okay. Any question? A question? Right. Let's move on. Now we need to have a displacement diagram. So I'll make a displacement diagram here. This is the height. And since one of it is simple harmonic motion, so we need a circle. We'll draw the circle, divide it. Let's say we divide it into 6 component or 6 parts. All right. Now come back to this phi A part, which is over here 120 degrees. Okay. You need to divide it. It's entirely up to you. Let's divide it into 6 parts and see. Okay, so this one is 0, 1, 2, 3, 4, 5, and 6. Then what we need to extend these lines. Okay, and extend from the center of rotation, crossing through the point 1, center of the rotation, point 2, center of the rotation, point 3, center of rotation, point 4, 5, and 6. 6 divisions here, 6 divisions there, 0, 1, 2, 3, 4, 5, 6. From here to here, pi a. 0, 1, 2, 3, 4, 5, 6. Simple harmonic motion, all we need is to take the reference from the circle. So 0 is 0, 1 is 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, and 6 prime. Okay? And you can see it's like simple harmonic motion. So all we need to do, transfer the displacement, distances, 0 to 0. So what we will get? The same point, 0 to 1, open the compass, 2, you go on 2, open it, come back here, 3, 4, 5, and 6. All of them should be labeled 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, 6 prime. Without labeling, it would be very difficult to see which point is coming from here to there, from the displacement diagram to the cam profile. Okay? And what's next? From here to here, it is delta 1. Okay, delta 1, the radius is same. So hopefully this point is also 6. If it is also 6, it should be same 6 prime. 6 again. Why? Because it's delta 1 and it's 6 prime. Okay. Then we have this pi d, 150 degrees. We need to divide it again into multiple component or equal component. Let's say or parts. We again divide it into 6 division, 1, 2, 3, 4, 5, 6 divisions. So the number is 7, 8, 9, 10, 11, and 12. Once we divide the arc into equal parts, then we need to extend the lines from the center, passing through the 7, 8, 9, 10, 11, and 12. Okay, coming back over here. Now this time, we decided to have uniform velocity. So how we are going to have uniform velocity? We'll join the straight line. So 7, 8, 9, 10, 11, 12. Therefore, for this part, we are using the straight line. Therefore, it is very important that all these are equally spaced. Okay. In simple harmonic motion, the reference is coming out of these lines. So even if they are not equally spaced, you will get the proper reference. Here, you rely on it. So you need to have a equal spacing between the line. 6 with 6 prime, 7 with 7 prime, 8 prime, 9, 10 prime, 11 prime, same point. This one is simple harmonic motion, and this one is all right. Let's go to take the references again. 6 prime, we already have it. 7, up to the point 7, and then 7 prime. Come back over here, mark it. 7 prime, 8 prime, 9, 10 prime, 11 prime, same point. Okay. All we need now, just like the previous one, we'll connect all the dots. This is optional part. You may not connect it, and you go on to the last part because this is not the required cam profile. Why? Because it is passing through the center of the roller. It should touch the end of the roller. So what you need to do now? You need to offset all of them. How much to offset? Same amount to the roller radius. Okay. So this 0 point will come over here. We'll open it and fix it to 7.5 in this particular case. It can be any other value depending upon the input data. So 1 will become over here, 1 double prime. 2 will become over here, 2 double prime, 3 double prime, 4 double prime, 5 double prime, 6. They all are the same. How much? Radius of the ruler. 7, 8, 9, 10, 11, and you may not need to match the previous one because it will add additional work because we don't need it. But the red one is the required cam profile. So all we need is to join them properly. So this is the required cam. File. So what is the difference between the case 1 and this one? Because case 2 is totally different because it was offset. In the case 1, we have a knife edge follower, which means it's basically point contact on the surface of the cam profile. This one is a roller. Again, a point contact, but in the form of the roller. Okay. So two things. What the first thing is the base circle you draw it in this one is RC plus RR. Okay. And just because you add it, so at the end, you just offset it again. That's the difference between the case 1 and this case